We're looking at a log here from andrenoite. I think my Brazilian Portuguese pronunciation may be showing. I don't know how that's said in Portugal. Um, uh, and Andre has a video and a log for us. We're going to look at both of them. I was not able to get the video to open up in Blackbox Viewer. I even tried converting it to a different format, and for some reason it wouldn't open. So there's probably a problem on my end, but we'll just have to look at them separately. The first thing I do want to point out, though, we know that the number 3 motor shaft is bent, so we can expect that there's going to be some extra vibration on this one. And we'll also take a look. We'll take a look at the gyros, and we'll also take a look at the motors and see, what that looks like. Since in this case we know what the problem is, so now we'll look at how it manifests, and then maybe that can help you guys go the other direction. If you have a bent motor shaft and you don't know, what is that going to look like in your motor traces? Before we do that, though, we're just going to take a look here at these settings, and the settings look completely nominal to me. Gyro LPF 188, gyro cut 60, P-term cut 40. All of that's just completely normal. D-term cut of 8 is on the lower end of normal. I don't think it's likely to be excessively low. However, I've recently started thinking about this issue of skidding back through your prop wash or on descent and getting bobbles. And there's been a suggestion that maybe excessively low D-term cut could exacerbate that. So I am definitely going to be thinking about that in the future as we start looking at these and exploring the idea of whether, if you're getting a lot of those, whether raising D-term cut may be the answer instead of lowering it. So we'll see about that. But nothing about this jumps out as abnormal. For Lux Float, these roll and pitch p-values, they are a little bit on the low side of the range that I typically see. That doesn't mean there's anything wrong, especially because it sure seems like Boris's changes to Lux Float have resulted in somewhat of a reduction in p-values, and who knows why that is. Well, maybe Boris does. I remember seeing Lux Float p-values in the range of about 1.2 to maybe 2.5, something like that. And it seems like everybody who's running Betaflight with the new Lux Float is getting values maybe in the 0.5 to 1.2 or 1.3 range. So nothing about that jumps out as well. The yaw P term is a little lower than I would normally expect to see. 1.5, I believe, is what is indicated here. And you can usually have yaw P significantly higher than maybe 2 or 3 times the value of pitch and roll. Although, and that's kind of what you've got here, actually. But I think there's a phenomena where, with Lux Float, as these numbers start to get lower and lower, the ratios that we normally expect to see start to skew a little bit, and it feels like we're kind of getting down to the bottom of an exponential curve where the relationship may be changing a little bit between the terms. So maybe yaw P could be higher, but I haven't even looked at the traces of the video, but that's just my initial analysis. Your TPA, I usually like to tune my TPA breakpoint higher than this. Now again, this is a matter of some preference for the pilot, and also different power systems are going to have different needs, especially because you know that you've got a bent motor shaft, so you've got excess vibration. You may be needing to tune that. But my gut instinct would be that if you need your TPA to kick in at 1475, then it may be that your P gains are too high. But if you had, for example, a very powerful setup, let's say you have a very powerful 4S setup, right? With maybe 4S with 50-45 or 60-45 props, and your hover point is like 20% on the throttle. Well, at that point, maybe this would make sense because your hover point isn't 1500 anymore. So if your hover point was 1500, you'd usually want to see TPA kicking in somewhat above your hover point, maybe 10 or 15% above your hover point. Because if you've got your copter tuned so that it's oscillating and needs TPA at hover, then it's probably overtuned. So I guess my assessment of this depends on where your hover point is. Let's take a look at the video now. And so one of the things I see as you're doing these little movements is that the movements are very sharp, very sharp. I'm going to try to put that in a more quantitative way. They start and stop very abruptly. And I want to point that out because this is independent of your rates. If you have low rates, it'll be hard to pick out the sharpness that I'm talking about. But I'm not really talking about the ultimate speed of the movement of the copter as much as it is how quickly it starts and stops moving, how abruptly it starts and stops moving. And that's indicative of P gains that are in the right range or maybe slightly overtuned. Again, this is a gray area that depends on your preference. But these movements are not what I would call soft in that they start and stop slowly or softly. Now I am seeing, and I am not sure if this is obvious especially with the frame rate of my video recording, which I'm only recording at 30 frames per second, but this video may be at 60, I don't know. But there's a little bit of what looks like noise-based vibration, oscillations, whatever, and they are these kind of semi-random, almost looks like maybe you're driving on a rough road and the car is kind of bouncing a little bit. Not oscillations. They're not regular like oscillations in that an oscillation is going to go back and forth in a regular repeated frequency. But these are kind of just little twitches and almost small enough that you wouldn't see them. But if you look, they're there. And that is sometimes a sign of inadequate gyrofiltering or excess determ. It may also just be a windy, turbulent environment. If you have a copter that's tuned, and I notice I can hear the wind, and I can kind of see the effects, some wind effects, so that's possible. If you have a copter that's really tuned to the edge, then if you put it in a windy environment, there's going to be noise effects. So as you punch out here, I feel like I can hear a little bit of oscillation in the motors. Let's listen again. And I could see a little bit of oscillation at the edge of your video. So if you look at the edges, that's where mostly roll-based oscillation is going to become the clearest. Right there. These are tiny little things to be noticing, but I want to point them out because, a lot of times we focus on black box logs, but I feel like if I was going to start looking at a tune, the very first place I'd want to look was the video and see if there's anything that points itself out there. I feel like you can get a very good sense of a tune from the video. And also, like I've said many times, and I still maintain, that if the video looks great, the motors and the ESCs are coming down smooth, then and you like how it feels as a pilot, then the black box logs are really incidental at that point. So I always want to look at the video first and try and get a sense of the tune from that. Here we've got a roll. Let's see what happens at the end of that roll. So we got some bounce back, but it doesn't look like there's any oscillation. Watch it again. And actually, I can probably play it back. There we go. At a slower speed. There. So there's a single bounce back. That's actually pretty good. That's indicative that our P may be in the right range, and maybe we just, those little oscillations we're hearing on punch out, maybe need just a little bit more TPA to tune them down, as opposed to reducing P. a little bounce at the end of a flip as well, and that, I'm sorry to say, uh, I still haven't figured out how to get rid of that myself. I'm just going to say it doesn't look too bad, and good luck with that. So now let's take a look at your black box traces, and I've got your gyros and your motors up to see how noisy your copter is. And I have to tell you, this idea that you have a bent shaft that's causing vibration, well, your gyro traces do not bear that out. Not that I don't believe you, of course, but I kind of, your gyro traces are really shockingly clean. And I kind of don't know what to make of it. It almost makes me wonder if I'm looking at the right log. Hang on. Yep, I just went and checked. I am looking at the right log. And your filtering is not super extreme. Your filtering is in the range of what I would call about normal. Gyro LPF 188, gyro cut of 60, p-term cut of 50. So I would say that look how thin these lines are. These lines remind me of what we used to see when people would fly gyro LPF equals 42. So if anything, it feels like this could be a little less filtered, and maybe you could get a little bit more locked in feel and better sort of responsiveness to changing conditions like prop wash by reducing your filtering. So I think, and I shudder to hear myself say this, but I think that you could even try increasing your gyro cut. Say gyro cut of 80 or 100 even, with p-term cut of 50, and see how that flies. Take a look at your just go back to Blackbox and look at your gyro traces, and let's say that they get twice as thick, between 2 and 3 times as thick as this, roughly. Not more than about 3 times as thick, just eyeballing it. And see what that produces, and if you like that result. This is really a very clean gyro. It's kind of a mystery to me why some copters are very clean and some copters seem very noisy. A lot of people are running very similar equipment, and I don't think a lot of people are going out of their way to like dynamically balance their props and motors on these little mini quads that most people are flying around here. But some of them seem really clean, and some of them seem terribly, terribly dirty, and who knows why. Uh, Here's a scenario where we see a motor maxing out as you climb up. So it is the case, and notice that the motors are more or less equal, but the back left is maxing out first. But the fact that it maxes out when you're at full throttle, I don't think we can really I don't think we can really blame it there. So I wouldn't call that a problem. You're at full throttle. One of the motors is going to max out. And what's happening here is that motor is maxing out, and the other motors are then being reduced by the PID loop to where they are proportional to that maxed out motor, uh, to keep the copter doing whatever it needs to be doing, staying level or tilted forward or whatever it needs to do. So anytime you go to max throttle, one of the motors is going to max out first, and the others will then remain proportionally below that, and there's nothing wrong with that. Um, I am now up at the end of a 15-minute video, and so we're going to call that, and I hope that was helpful. And you did actually have one question about your D term. Let's just take 30 seconds and look at that real quick. Well, I look back at your post. You didn't ask a question about your D term. I mentioned that your D term filtering may be lower than it needed to be. And I especially think that's true given how clean your gyro traces are. So you may get a little bit better flight feel by raising D term from 8 to 10 or 12, maybe even higher than that. Um, there is a thing that LuxFloat seems to do, and I think it's a black box thing, where with some of the LuxFloat traces, the lines are very small, and I don't know what that's about.